Since December 2021, the James Webb Space Telescope has revealed many secrets of our universe. This yielded new images of galaxies that complemented images from the Hubble Space Telescope and expanded our understanding of supernova remnants that peer into the early universe. This spacecraft has already made important discoveries. In its latest observations, the powerful Webb telescope captured a new deep field of the universe, giving a glimpse into the far reaches of space. This image shows hundreds of objects in the middle of the black ether of space. These are galaxies, each full of stars and planets, many of which resemble spirals similar to our Milky Way galaxy. The deepest galaxies appear red because the expanding universe has extended its light to longer wavelengths. This view looks back billions of years, revealing ancient galaxies and black holes at their centers that merged just a few 100 million years after the Big Bang. In the very beginning, the cosmos experienced a period of rapid expansion. Space expanded exponentially, removing a form of reality and creating an almost irrelevant void. If you could sit on top of an atom, before atoms existed, and look out, you would see nothing but frozen, stifling darkness as space continued to expand. All other objects were moved out of sight, faster than the speed of light. Paradoxically, as space expanded, the observable world shrank into a tiny, inescapable nutshell, isolating each point in its own sphere of nothingness. This era of extreme expansion is called inflation. Its duration remains a mystery. Whether it lasted a moment or an eternity, we may never know. This cosmic growth has removed all traces of previous ages. Once, however, inflation stopped and the universe was born. The force behind inflation weakened and produced countless particles that filled the expanding void with floating subatomic fire, the element from which all cosmic objects would eventually emerge. Within a trillionth of a second, the fundamental forces of nature manifested, marking the first and largest light trail in cosmic history. Although inflation has stopped, economic growth has continued at a slower pace. As the cosmos grew, the primordial fire cooled and the elementary particles came together to form the first atoms. Over the next few minutes, cores of hydrogen, helium, and lithium were forged, the building blocks of everything to come. For about 380,000 years, the infant universe burned with a fiery fire that gradually cooled as the cosmos expanded. Then came a critical moment when the temperature dropped enough for electrons to bond with atomic nuclei, forming the first perfect atoms. At that moment, the primal flame went out and plunged into the darkness of space. This began a long dark time. For hundreds of millions of years, the universe was surrounded by a hot hydrogen nebula. However, in this darkness, the first structures began to form, at first slowly, then accelerating. Hydrogen and helium combined under the influence of gravity to form denser clouds that warmed as they condensed. Eventually, the pressure in the core of one such cloud reached a critical point and ignited a nuclear fire, the spark of the first star. The light of this newborn star flowed back into the universe, marking the end of the Dark Ages and the beginning of the cosmic dawn. Soon the universe was full of stars, which gathered in the first galaxies. These stars synthesized elements such as carbon, oxygen, nitrogen, and iron, which spread through space when those first stars died in a supernova. They seeded space with even more elements and observed the cycle of birth, death, and rebirth. About 9 billion years after the cosmic dawn, a new star twinkled in the outer spiral of one of the billions of galaxies now scattered in space. A bunch of worlds revolved around it, and on one stone sphere, the Earth, matter somehow came to life. Driven by basic physical forces, atoms split into increasingly complex organisms that have grown, reproduced, and evolved over billions of years. The pale blue globe was full of life. Species were born, flourished, and disappeared in a continuous dance of evolution. Finally, humanity appeared, standing on the Earth, looking at the stars, pondering their origins and the vastness of space. This story of the cosmos, its origins and history, has been painstakingly compiled over centuries by the collective efforts of thousands of people. Modern science allows us to confidently discuss events both ancient and distant, stretching our imaginations. This feat is one of the greatest of our species, for it was accomplished from the surface of a rock hurtling through the aimless vista of space. Although we understand some of the early universe, data from particle physics and astronomy show that we still understand only a fraction of the cosmos. Looking at the sky, it becomes clear that matter is organized on a large scale into galaxies and clusters of galaxies. Galaxies contain stars, planets, and gas. Everything visible in the universe, including the Earth, Sun, stars, and galaxies, is made up of protons, neutrons, and electrons bound together to form atoms. Physicists have developed a deep understanding of the fundamental particles and forces that govern the ordinary matter that surrounds us. Centuries of discovery have taught us why apples fall from trees, how the Earth revolves around the Sun, and that the Earth is not the center of the universe. This picture is simple and elegant, but the quest to answer fundamental questions about the universe has reached a defining moment. Astrophysical and cosmological observations have shown that our understanding of the universe is still incomplete. One of the most amazing discoveries of the 20th century was that ordinary matter makes up less than 5% of the total mass of the universe. The rest consists of dark matter, a mysterious invisible substance, and dark energy, a force that opposes gravity. Dark matter, an exotic substance, does not emit, absorb, or reflect light, making it invisible. Its existence is due to its gravitational influence on galaxies. Stars about 10 million times the distance between the Earth and the Sun move at the edges of rotating galaxies at almost the same speed as nearby galaxies where visible matter is concentrated. This phenomenon is related to the gravitational influence of an invisible mass, the dark matter halo surrounding the galaxy. Dark matter may also explain optical illusions seen in deep space, such as strange rings and arcs. These distortions occur when light from distant galaxies is bent and magnified by massive, invisible clouds of dark matter in a phenomenon known as gravitational lensing. The radical conclusion that the universe is filled with almost imperceptible matter reflects past paradigm shifts, such as the realization that Earth is not the center of the solar system.
Like normal matter, dark matter originates from the Big Bang. Its spread affected the evolution of the universe, causing the formation of stars and galaxies in regions with higher concentrations of dark matter. The cosmic web we observe today reflects the distribution of dark matter in the early universe. This mysterious substance acted as an invisible force that controlled the growth of galaxies. Exploring this unknown universe requires a deeper understanding of the fundamental physics of dark matter. Recent advances, such as the James Webb Space Telescope, point to discoveries yet to come. Recent telescope images have revealed possible dark stars, objects that may be powered by dark matter, the invisible substance that dominates the universe. Scientists first proposed the existence of dark stars in 2007, led by cosmologist Catherine Fries of the University of Texas at Austin. According to Fries, dark stars would be fundamentally different from ordinary stars like our Sun. While ordinary stars get their energy from the nuclear fusion of hydrogen atoms, dark stars can get their energy from the destruction of dark matter particles. Dark matter, whose nature remains transient, gravitationally interacts with visible matter such as galaxies, but can also interact independently, generating enough heat and light to form and sustain these celestial bodies. These dark stars could not form in the modern universe due to the scarcity of dark matter. However, they may have appeared in the early universe shortly after the Big Bang, when clouds of hydrogen, helium, and dark matter were abundant. The dark matter particles annihilated each other in these clouds. The resulting heat prevented complete collapse, causing these bodies to grow extraordinarily large, up to 10 times wider than Earth's orbit around the Sun and potentially billions of times more massive, and light like our Sun, or even the entire galaxy. The James Webb Space Telescope, designed to study ancient and distant cosmic objects, may have already detected signs of these hypothetical dark stars. Fries and his colleagues analyzed Webb's observations of high redshift galaxies dating back nearly 14 billion years. They identified 3 candidate objects, JADES, GS, Z13-0, JADES, GS, Z12-0, and Jades, GS, Z11-0, with properties similar to those of dark stars, high redshifts, and possibly star-point emission, instead of nebulous galaxies. Confirming the existence of dark stars would provide compelling evidence for the existence and behavior of dark matter. It may also provide insight into the formation of supermassive black holes, which are mysterious in origin despite their prevalence in galactic centers. These cosmic giants, millions or billions of times more massive than our Sun, can form from the remains of dark stars after their dark matter has been destroyed. Essentially, our journey to cosmic dawn continues under the guidance of the James Webb Space Telescope. Each discovery brings us closer to unlocking the secrets of the early universe and understanding the forces that shaped it. The high redshift galaxies detected by Webb act as time machines, allowing us to peer into the past and get closer to understanding the mysterious origins of the cosmos. Explorers of the unknown, we stand on the brink of discovery, ready to uncover more mysteries of the universe. According to recent news, scientists using NASA's Space Telescope have made an exciting discovery, a fascinating world about the size of